How to design PBCH? Explain all the parameters with equations. So designing the PBCH physical broadcast channel in a 5G NR system involves understanding its structure, associated parameters, and the way it's mapped to the physical resources. PBCH carries MIB, which is critical for initial cell access and system information decoding by the UE user equipment. Overview of PBCH. Purpose: PBCH carries the master information block, which includes system information necessary for UE to access the network. PBCH carries the MIB, master information block, which includes system information necessary for the UE to access the network. Carrier. It is transmitted over the SS PBCH block SSB, which includes synchronization signals PSS, SSS, and PBCH. Frequency domain occupies 240 subcarriers, 20 resource blocks over a 12 subcarrier spacing grid. Occupies 240 subcarriers, 20 resource blocks over a 12 subcarrier spacing grid. Time domain occupies 3 or 4 OFDM symbols depending on configuration. Okay, purpose: PBCH carries the master information block which includes system information necessary for the UE to access the network. Carrier: it is transmitted over SS PBCH block SSB, which includes synchronization signals PSS, SSS, and PBCH. Frequency domain occupies 240 subcarriers, 20 resource blocks over a 12 subcarrier spacing grid. Time domain occupies 3 or 4 OFDM symbols depending on configuration. So key parameters of PBCH design: subcarrier spacing delta f. So delta f is equal to 2 raised to mu into 15 kilohertz. Mu is 0 to 4. PBCH is transmitted with $mu is equal to 0. Delta f is 15 kilohertz in FR1 sub 6 gigahertz. In FR2 it can be transmitted with delta f 60 kilohertz. Resource grid for PBCH: frequency domain 240 subcarriers, 20 resource blocks into 12 subcarriers. Time domain 3 or 4 OFDM symbols depending on cyclic prefix length and configuration. Modulation scheme: PBCH uses QPSK modulation. Each symbol carries 2 bits. Coding: PBCH uses polar coding with CRC attachment. CRC is 24 bits, payload 32 bits, master information block plus additional bits, optional for system input. Total input bits to polar encoder up to 64 bits. Rate matching to fill the required number of QPSK symbols. CRC 24 bits, payload 32 bits, a master information block plus additional bits optional for system input. Total input bits to polar encoder up to 64 bits. Rate matching to fill the required number of QPSK symbols. PBCH payload and mapping. PBCH payload consists of system frame number, inscription 6 LSB of the frame number, subcarrier spacing common SCS used, SSB subcarrier offset of SSB, half frame indicator indicates which first or second half, PDCCH config SIB1, PDCCH config for SIB1 scheduling, cell barred access control, intra frequency reselection whether UE should search other cells. PBCH symbol mapping. After coding and modulation, symbols are mapped to physical resources. After coding and modulation, the symbols are mapped to physical resources. Demodulation reference signals DMRS are multiplexed with PBCH symbols using time and frequency division multiplexing. Equations and calculations. Total number of PBCH QPSK symbols needed. Let K be the number of information bits and N the number of encoded bits after polar encoding and rate matching. Each QPSK symbol carries 2 bits, n QPSK n by 2. For example, n is equal to 864, 432 QPSK symbols. Okay, total number of PBCH QPSK symbols needed. Hmm, n divided by 2. Rate matching adapts the output of polar encoder 1024 bits to match the available physical resources. E is number of bits required for mapping, n is output from polar encoder. The rate matching is done to get exactly E bits from n encoded bits. Resource mapping formula. Let n SC SSB 240 subcarriers, n SSB is symmetric 4 symbols. PBCH occupies 3 symbols, symbol 1 to 3. NRE PBCH total available resource elements minus resource elements for DMRS. Hmm. PBCH occupies 3 symbols, symbol 1 to 3. NR resource element PBCH total available resource elements minus resource element for DMRS. Typical total resource elements for PBCH in one SSP is NRE PBCH 240 into 3 minus NDMRS. NDMRS is 144, depends on configuration. DMRS generation. Next, DMRS is generated using a pseudo-random sequence based on physical cell ID, PNN, CINIT, CINIT, physical cell ID. The sequence is QPSK modulated and inserted in predefined resource elements. SSP indexing and beamforming. Each PBCH is a part of a SSP which may be repeated across beams, beam sweeping, maximum 64 SSPs per carrier. SSP index ISSP is used to determine beam association. Okay, summary table, parameter subcarrier spacing delta F 2 raised to mu 15 kilohertz, typical PBCH. Bandwidth is 240 subcarriers, 20 resource blocks. Time symbols is 3 or 4 with CP. Modulation is QPSK. Coding is polar code with CRC. Payload is 32 to 64 bits. Output bits 864 bits. Rate match. QPSK symbol is 432. Reference signals are DMRS multiplexed. Sequence generation PN sequence based on cell ID.